Hi everybody, this is Angelbert Morales from E. Rodriguez Vocational High School. Welcome to Aghamazing. Our today's episode is about vector and vector addition. To start with, let's compare the scalar quantity and vector quantity. Scalar quantity is a quantity contains magnitude only. Vector quantity contains magnitude and direction. Example of unscalar quantity are number 1, we have the mass. Number 2, distance. Number 3, speed. Number 4, time. Number 5, temperature. Number 6, area. Number 7, volume. Number 8, density. Number 9, amount of substance. Now, let's have an example for vector quantity. We have the weight. Then we have displacement. Then velocity. Then we have acceleration. Then we have the force. Then we have momentum. And lastly, we have the pressure. So those are the vector quantities. Just have a recap on it. So we have the weight, displacement, velocity, acceleration, force, momentum, and pressure. Now, let's differentiate scalar and vector quantity. I have here an example of the different physical quantity with something in common. Example is mass and weight. Mass for the scalar quantity, weight for the vector quantity. The SI unit for mass is kilogram. For the weight, we have Newton or kilogram meter per second squared. Now, let's define the mass. Mass is defined as the amount of matter it contains, while weight is the product of mass and acceleration. Weight is equal to the product of mass and acceleration, while mass, we only have the amount of matter it contains. Now, let's have another example, the distance and displacement. Scalar quantity for the distance. Displacement for the vector. The unit for distance is meter. The unit for displacement is also meter. However, there is a direction in displacement. The distance with the magnitude, we have d is equal to 5 kilometer. While in displacement, we have d, then with an arrow to represent that this is a displacement. For example, we have the value 5 kilometers north. Then the north indicates a direction. Therefore, displacement is a vector quantity. For the third example, we have the speed and velocity. Speed for the scalar quantity. Velocity for vector quantity. So for the speed and velocity, let's have the value or the magnitude and direction or the physical quantity it represents. For example, B is equal to 5 km per hour. So this is for speed. For the velocity, we have 5 kilometers per hour, 30 degrees north of east. The 30 degrees north of east indicates direction. That's why velocity is a vector quantity. So let's have now the recap of Scalar and vector quantity.
Example of scalar quantity are mass, distance, speed, time, temperature, volume, area, and density. Example of vector quantity: weight, displacement, velocity, acceleration, force, momentum, pressure, and impulse. Parts of the vectors are tail, length of an arrow, and head. Tails give us the point of origin. The length of an arrow gives us the magnitude. And lastly, the head for the direction.
Now, let's go to the vector addition or additions of vectors. We have here an illustration of vectors. In situation 1, we have 1 kilogram going to east and then added by 2 kilometer east. We're going to have 1 kilometer east and 2 kilometer east. How many vectors do we have? We're going to add it. Correct. That is 3 kilometer east. If you're going to notice, guys, I put that here so that we can indicate, we can identify if where is the 1 kilometer and 2 kilometer. This is the 1 kilometer east. This is the 2 kilometer east. That's why if we're going to add 1 kilometer and 2 kilometer east, we have 3 kilometer east. Now, let's have the opposite on the second situation. We have 1 kilometer east and 2 kilometer west. So we have 1 kilometer east and then we have 2 kilometer west. Therefore, we have opposite direction, we subtract. Okay? So how many kilometers do we have? That is 1 kilometer west. So 1 kilometer west. So in that case, if we have rule number 1 for adding your vectors, the same direction, you simply add. Opposite direction, you subtract. But in the situation number 3, what happened? We have 1 kilometer at a certain direction or angle. While here, we have 2 kilometer west. Can we simply add it? Of course, we cannot add it because they are not on the same plane or they are not on the same axis. Same axis or Cartesian plane that is on x-axis and the y-axis. Okay? If we say different direction, it can be opposite in the direction or it can be on the different angle. This time, on rule number 3, we cannot add the two vectors, but somehow there are different methods in identifying or solving our vector addition. Number 1 is component method. Number 2 is the polygon method. And lastly, the graphical method. Before we go on to the vector addition of the two vectors or more, let's start first with identifying the direction. Because I know that some of you or some of the students are not that familiar in finding the direction. To start with, we have here the Cartesian plane. We have to be very careful in identifying the direction. The first one is the north. We're going to locate the north. The north is always at the upper portion. North. This is our north. Of course, S stands for the lower portion. That's why south, lower portion. And then, don't forget that we are at the middle. We. We are at the middle. Don't forget that one. That's the Q. North for the upper portion and S for the lower portion, and we are at the middle. The middle of the north and east is what we call what? North east or east north. That is if that is in 45 degrees. Both of it is 45 degrees. If it is not 45 degrees, then you will use north of east or east of north. Okay? Now, suppose that the vector is located somewhere here. Let's name this as D1. Suppose the D1 is located here, 10 degrees. So how do we name this one? That is north of east because it is located in east. That's north of east. Okay? Meaning also your angle is from east going to north. Okay? So meaning you are going to north. That's why that is north of east. 10 degrees north of east. However, if your angle is somewhere here, suppose this is 10 degrees also. Let's name this as D2. And it is located in north, going to east. Therefore, we name it as east of north. Okay? Now, let's go to another quadrant. Okay? Let's go to east and south. If the angle is somewhere here, the theta is somewhere here, we name it as south of east. If it is in here, the vector is here, located here, then we have east of south because it is going to east. This one going to south. That's why it is south of east. Okay? Let's have another quadrant. So south and west. If the vector is located here, we call this vector as south of west. Because we are now on west. So now here we have south east or west of south. Okay? The theta is somewhere on south. That's why west of south. Okay? Going to west. That's why it is west. Okay? On the other way around, for the last quadrant, we have here north. We have here west of north. And then north of west. Guys, if you don't remember the location or the direction of your vector, you can use this free body diagram. Let's call this as free body diagram 1. Okay? For the direction. I want you to write it on your notebook so that you can check your direction if you think it is very confusing with you. So meaning, this is your guide in locating your direction of vectors. Now, let's go to a very simple vector. And of course, we have to start with the triangle first. You have to be familiar with the triangle first before going to vector. Let's start with this triangle. So as you can see, I write x, y, r. So the angle of inclination or the theta is opposite on y. Okay? That's why we call this opposite. And then the things that is been adjusting, we call it as adjacent. And then this is the hypotenuse. Okay? If you still remember your SOHCAHTOA, you can understand the vectors immediately. I want you to put this into your mind that you have to remember the SOHCAHTOA. SOHCAHTOA. Let's start with the SO. So, S stands for the sine theta. The O slash, we have the slash O over the H. And the opposite is the Y. This is the adjacent. This is the hypotenuse. Therefore, what is this? We have the opposite. The symbol for opposite is Y. The symbol for the H is, or the hypotenuse, is the R. Therefore, sine theta is equal to Y over R. Okay? Now, let's go with the Ka. Ka, the C stands for cosine theta. Slash, we have the adjacent over the hypotenuse. What's the symbol for the adjacent? That is X. Correct. On the hypotenuse, we have the R. Correct. Therefore, the cosine theta formula is X over R. Okay? So this is our cosine theta. This is our sine theta. Let's go now with the TOA. T stands for tangent theta. Then slash, we have the opposite over the adjacent. The opposite is Y. Adjacent is the X. Therefore, tangent theta is equal to Y over X. So that is the SOHCAHTOA. Okay? Why do we need to study this one, this SOHCAHTOA all about? Because SOHCAHTOA is something to do with the vector. Some of the teachers don't know that this is very necessary. That's why I'm implying you and saying this to you that you have to remember the SOHCAHTOA. Okay? You have to remember this because every now and then you're going to use this in your vector addition. Now, let's go over to the problem solving. But of course, before we go to it, let's just have some important things that you have to be remembered. There's always two components, the Y component and the X component. The Y components are along the X-axis, while the Y component is along the vertical axis. Okay? If solving for the component, X component, if the angle is along or from the X component, we use cosine theta. While on the Y component, we use sine theta. However, if it is opposite, meaning this is the Y and this is the X, the angle of inclination is here. Okay? Or the theta or the angle is here. Not on the X-axis, but located along the Y-axis. Therefore, you're not going to use cosine in X component, but instead, you're going to use sine theta. And then, cosine theta on y-axis or y component. And then, guys, we'll be having the d1x. Suppose we have first vector. Vector 1, let's name this as d1. If the d1 is connected on a Cartesian plane, of course, we have the direction first. North, this is the south, this is the west, this is the east. And it is located here. The theta is located here. So suppose this is 2 kilogram. Then, we'll be having the y component and the x component here. So, to get the x component, because our x is with respect to the d1, we're going to write d1x. So, we just put d1 here so that we respect the d1, the present vector, d1. Also with the y component, d1. Okay? That's why we have d1y. But of course, if we don't have the name of the hypotenuse, then we don't have the d1. But if we have d1, we name this as the x component and the y component as d1x and d1y. If this is acceleration, a1, then this will be a1x, a1y. Okay? If that is force, F1, so then this is F1x, F1y. So to complete the x component and y component with respect to the distance 1, let's put it here. So therefore, the formula here for the x component, in order for us to solve for the d1x, is d1 cosine theta. Here, we'll be having d1y is equal to d1 sine theta. So, in the opposite, this one, so this is good for the opposite. No? So, we will be having d1x, then d1 sine theta. Here, d1y is equal to d1 cosine theta. So, there is an opposite, okay, a reverse of this trigonometric function. Okay? Now, let's go over to the problem itself. This is our problem number 1. Okay? Let's name this as problem number 1. Suppose there is a distance covered by a mobile, 2 kilometers going to north. Then afterwards, it covers another distance of 5 kilometers, 30 degrees north of east. Okay? So we're going to draw the free body diagram first. The first thing that you have to do is to draw the free body diagram. Let's name it as free body diagram 1. Okay? The first thing that you're going to do is to make a Cartesian plane. Okay? So the Cartesian plane must have the direction. Earlier, we discussed the direction. So the upper portion is the north. The lower is the south. And we are at the middle, B. Okay? So the given is 2 kilometers north. So it is located here. We just estimate the allocation. Okay? So therefore, this is the 2 kilometer north. Okay? So let's name this as D1. Okay? Then 5 kilometers north of east. So therefore, we have the north and then the east. North of east, meaning the D-sub 2 is going to north. Okay? So 30 degrees. So half of this is 45, so it should be closer to the east. So that's why we'll be having it this way. So this is, we just estimate the angle of inclination, okay? But in graphical method, we're not going to use estimation, but instead we're going to use protractor. You have to use protractor in order for you to have an accurate value. Now, Of course, the D1 don't have the x component. While the D sub 2, this is our D sub 2, this is 5 kilometers, this is 2 kilometers. Okay? So, there is a 2 component here in D sub 2. We have D2y and then D2x. Okay? This is the x, this is the y. With respect to the D2, we put D2x, we put D2. That's why we have D2x and D2y. Okay, you understand? So that is our free body diagram. Let's go over to the problem solving itself now. So let's solve it now. I'm going to erase this now. Okay? To solve for the component, by the way guys, we need to calculate the resolutions of vector. And what is this resolution of vector all about? The resolution of vector is the complete vector or the sum of all the vectors that we have. And what are the component or the quantity included in it? So resolution of vectors can be in a magnitude. So we have to calculate the magnitude. Okay? And then the theta or the degree. Okay? Then we have the direction. So these are the things that we're going to solve. No? So the three. Okay? Now, let's start with the magnitude. How do we get the magnitude? Of course, we start with the x and y component. We have to solve for the summation of x and summation of y. Okay? So, let's start with the x component. Okay? If you're going to notice, we don't have d sub 1x. But instead, this is the d1 is the d1y. No? So, therefore, this is the d1x is what? We don't have the d1x. What do we have? We don't have. So, 0. Okay? So, that is 0. d1x is 0. Now, let's go to the y component. We only have y component. Therefore, the d1y is equal to 2 kilometers. Very good. And what's the direction? North. Okay? We just copied the given. Okay? Now, let's go to d sub 2x. So, d sub 2x is, because we have the component d2x and d2y, so we'll be having d2 cosine 30 degrees. Why do we use cosine 30 degrees? Because it is looking, or the angle is located along the east. Okay? So, the angle is in the east, not on north. Okay? So, on d2y, we have d2 sine 30 degrees, or theta. So, let's substitute. This is 5 kilometers, and then cosine 30. By the way, guys, to calculate it, be sure that you have your scientific calculator. You press cosine 30 first. Okay? So, the value is 0.866. Okay? Okay? By the way, guys, we're going to use 2 digits after the decimal point, except for the 30 degrees. Okay? And 60 degrees. Okay? So, we multiply. So, 0.866, the one that you get from your calculator, you multiply it by 5. So, what we have, 4.33 kilometers. d2x. Okay, now, how can we get the direction of the d2x? Okay, where's the d2x? Is it in east or west? Is it in east or west? Right, that is in east. Therefore, the direction here is east. Okay? Now, let's go to D2y. So D2y, we have 5 kilometers. Then sine 30. So press sine and then 30 degrees. 0.5. Okay? So we put 0.5 here. So times 5. So we have 2.5. So D2y is 2.5 kilometers. Oh, what's the direction? Okay, now, to get the direction, where is the D2y? Is it on north or south? Again, where is D2y? Is it in north, going to north, or going to south? It is going to north. So, the direction is north. Okay? Now, to get the summation of x, we simply add. Okay? d1x plus d2x. Okay? Here, we have the summation of y, d1y plus d2y. Okay? So what's the value? So here, that's 0. And then, we just copy. No? The answer is 4.33 kilometers east. So that's the summation of x. Okay? So that's the summation of x. For the summation of y, we have, okay, so we have north, north. The same direction, therefore, we simply add it. However, if this is south and then this is north, opposite direction, so we subtract. But this time, we don't subtract it. We simply add. So we have 2 and 2.5, that is 4.5. So 4.5 kilometers. What's the direction? Okay, north. Okay, north. Now, so we're done on the summation. But we're not yet done on the magnitude. We don't have yet the magnitude. And how do we get the magnitude of the vectors? To get the magnitude of the vectors, we use c is equal to the square root of a squared plus b squared. And what is this all about? We can also substitute this to another representation. That is, r is equal to the square root of x, summation of x squared, plus the summation of y squared. Okay, next. We substitute the given value. And the value for x is 4.33. So 4.33, then close and open parentheses, squared, plus 4.5, 4.5, then squared. So don't forget the radical sign. Okay? So just put the radical sign again. So 4.3 squared. So you squared it first. You square it first. So we have 18.75 plus the 4.5 square, so 20.25. So we add this plus 18.75. We have square root of 39. So what is the square root of 39? 6.24. So the R is 6.24 kilometers. Okay. So the magnitude is 6.24 kilometers. Okay? Do you have any question, guys? Okay? So, this is our magnitude. So, we get the value of magnitude by getting the x component, y component, and the Pythagorean theorem. Okay? So, this is now for magnitude. So, let's go over to the angle. Okay? So, for angle. Okay? And how do we get the angle? The angle can be solved by tangent theta is equal to the summation of y over the summation of x. Okay? So, what's the value of the x? We have 4.33. And then 4.5 for the y. Okay? So, don't forget your cycle. You get your cycle, you divide the value. So, 4.5 divided by 4.33. So, we got 1.04. Okay? 1.04. So, this is tangent theta. What we need is the angle. So, we have, to get the theta, we have theta is equal to arc tan negative 1 and then 1.04. So, what is arc tan all about? That is the inverse. Okay, the inverse of tangent. Okay. So, we get inverse tangent of 1.04. So, we got 46.12. So, theta now is equal to 46.12 degrees. Okay, so these are angle. Or, simply, theta is equal to 46 degrees. Okay, let's just use 46 degrees. Okay, now, so our theta here is 46 degrees. So, how do we get the angle or the direction? Of course, we have to use the summation of x and summation of y. So, this is our free body diagram 1. No? Then, we have to write FBD2. So, if we have FBD2, so I will lie down here so that you can see what's happening on the direction. So, you have to create your Cartesian plane. So, we have the north, south, west, east. Okay? The summation of x, we start from x. So, summation of x is east. And that is 4.3 or 33. So, it is somewhere here. Okay? So, this is our summation of x. Okay? So, then we have, so, if the direction of the summation of y is going upward, you put it downward. If it is on the downward, you put it upward. Okay? So that you can identify. Then, you create the another small Cartesian plane. Okay? Small Cartesian plane. So, this again, north is south. Of course, this is west. And this is east. Okay? So, let's, okay? So, then, we connect the north. So, almost need the same value, 4.5, no? So, we put here the 4.5. These are summation of y. Because the summation of y is north, that's why it's going upward. Then we connect this. So, this is now our r. So, the r is theta here. The theta is there. So, we have the summation of x connected with the summation of y. Then, that's the r. Okay? So, where is the theta located? It is along east. Therefore, the theta is going to north. That's why that is north of east. So, to complete that unknown, we put north of east here. So, the resolution of vector now is 6.24 kilometer, 46 degrees north of east. Okay? So, we know now how to compute the resolutions of vector in two vectors. So we don't simply add it. Okay? So by the way guys, let's just have a recap. Rule number 1 in adding a vector. The first one, if they have the same direction, we simply add. Okay? If it is north, north, we simply add. If it is south, south, simply add. And so on and so forth. On rule number 2, if it is opposite direction, for example, we have going to east and then going to north, or going to east and then going to west, that's opposite direction, we subtract. North and south, we subtract. That's rule number 2. In rule number 3, we cannot add the two vectors, but we can use the 3 different methods. What are these 3 methods again? So we have the component method, polygon method, and the graphical method. At this time, I just present to you the component method. I hope you learn a lot from this lesson. So, this is Angelbert Morales, your guide for today in Amazing, because science is always amazing. Bye-bye!